In this video, we're going to be taking a look at the connection between adding and subtracting. So that's what that means. And what I like to do is I like to change every single subtraction problem into an addition problem. And the how and why of why I like to do that, we are going to kind of get into here. Now, do we have to do it that way? No, but it does for, I believe, like 99% of students, it does knock down on some of the errors that students make when adding and subtracting. Even upper level students, it helps with them, prevents them from making so many mistakes too. Simple mistakes. So for example, looking at this is just to show that they are the same thing. Choose a number for A. So let's say A is -2 and B is 7. Okay? So we're plugging it in for A, and we're going to do this one first. So then we're going to do -2 plus, and it says -B. So it's going to be a -7. We're going to look at that answer. We're going to compare it with just A minus B. So that's just -2 minus 7. When we go through and solve these, we're going to end up getting the same thing. Both of them are going to be -9. Right? Whereas in the first one, you added a negative, so a number plus a negative number, versus the second one, it was just a number minus a number. Okay? So just to show that they are exactly the same, and like I had mentioned at the opening of this video, this is what I prefer right there, time and time again. Especially when there's negatives in there, you can just use the word combine when you're talking about adding versus finding the difference of. Okay, so that's what I like to do, and that's the way that this lesson kind of teaches it. Now, again, is it necessary? No, but it does reduce, in my 20 years experience, it does reduce the errors that students are going to make when adding, subtracting. So a lot of these are just showing students that the fact that they are the same. Okay, like here we have a chipboard. On this chipboard, the chipboard below shows a value of +5. So you have those 5 black, and that's where that +5 comes in, right? So then it talks about different changes that you could make. It says there are 2 possible moves, 1 addition, 1 subtraction, that would change the value on the board to +2. So our goal is to get a chipboard that then looks like this, right? So there's different ways we could do that. Number one, we could do that just by removing 3 black. Okay, just getting rid of 3 black. The other way to think about this is by adding 3 reds, because if you add 3 reds, then those will cancel out with 3 blacks. So if we look at this problem down here, +5 plus what number will give you +2? And in that case, that's where we added those 3 reds and got +2, 2 blacks. And in here, +5 minus what number? Well, that's when we just took away the 3 blacks to get, whoops, there we go, +2, because 5 minus 3. Now, I understand when I say that I prefer this, I mean that 100% of the time. However, I see that just taking 5 minus 3 equals 2, that's fine, right? But this is representative of maybe from here on about 30 to 50% of problems students are going to encounter. All the other ones are going to look like this. Positives and negatives are intermixed. Sometimes both are negatives. The bigger one's negative, the smaller one's negative. In this case, the smaller one's negative, so it's not a big deal. It's what we're used to learning about in elementary mathematics. But now when the bigger one's negative, or the one on the left is negative, it causes confusion. This way, if we think of it just as adding them together, it might be a little bit easier. So number 2 says, how would you complete the number sentence below to change the value on the board to +8? Right, so now we're going up to 8. Again, you could think of adding 3, right? Or subtracting a -3. So taking 3 negatives, and this is what this looks like. If I'm taking away 3 negatives, you see there are no negatives on there. But what I could do is I could add 3 positives and then take away 3 negatives. Okay, so now those are 3 negatives. I can take away those 3 negatives and I'm at 8. So that's what this one is saying here. The great thing about this is all of mathematics is a language, and trying to use that language to do what you want it to do, like computer science is a language of mathematics because computers only speak math. And just getting mathematics, the numbers, to do what you want them to do and understanding the rules is huge, right? And I understand, like, well, we could just add 3. I get that. But understanding the language beyond the basics is really important in learning to love this language of mathematics and learning what does it do for me, how can it make me enjoy my life better, and how does it make my computer run, right? Just understanding manipulation of mathematics to get it to do what you want to do is hugely important, okay? So just so you can see visually what it looks like when you're adding a negative or subtracting a negative in that case. How are we doing on time? Okay. So on these, you're just completing the number sentences. They're not that tricky. You know, positive 5 plus negative 4 is the same as positive 5 minus 4. Negative 7 plus negative 2 is the same as negative 7 minus 2. You get the same answers there and there, there and there. And then over here, positive 5 plus a positive 4 is the same as positive 5 minus a negative 4, right? Because minus a negative, as we saw above, takes away, makes it positive, turns it to plus a positive, like this one right here. And then negative 7 plus positive 2 is the same as negative 7 minus negative 2. All right, so just understanding that there are different ways to write things is so much better. Understanding different words to say different things in a different manner with different feelings. We're doing the same thing here, only with numbers. Okay, then go ahead and answer number 2 on your own there. Looking at part C, you're doing something very similar to what we just did. So go ahead, pause the video and fill out A through D there. So on these, you should get 8 minus 5 is the same as 8 plus a negative 5. 8 minus a negative turns into plus a positive. You can probably should put the positive here. After this lesson, we won't be doing that. But for right now, to show that that's a positive 5 or a positive 6, you can put that there. All right, so check your answers, see how you did, and then answer number 2, talking about the patterns that you see. That's very important, just kind of reflecting on what are the patterns. Mathematics, just like a language, I've been saying that, is all about the patterns. It's completely predictable, right? God wrote this language so that we could understand the world around us a little bit better. And that we can predict what might happen in the future, right? So look for those patterns. If we take a look at D, it's very similar, but for this one, what they want you to do is, like on number 1, they want you to write an equivalent expression. So we're going to rewrite this in your notes. Just like all of these, you should be rewriting all of this in your notes. Your notes you want to be useful and helpful for when you go and study for quizzes and tests. So we're rewriting that, then we're going to rewrite it in a different way. So instead of plus negative 5, we're going to write it as negative 5 minus 5. Instead of minus a negative 5, we're going to write it as negative 5 plus a positive 5. You can even put a positive 5 there if you wanted to, okay? So you're rewriting all of these in a different way, and then you're finding the answer. So negative 5 plus negative 5 or negative 5 minus 5, this is where this could be confusing because this looks like 0, but it's actually negative 10. And this is a good example of why I like to turn everything to an addition problem, right? Negative 5 plus a negative 5, you're combining 2 sets of negatives, which gives you a bigger set of negative, and we get negative 10. All right, so go ahead and do that for all of these and then come back and see how you did. So pause the video right now. And so here I rewrote them all, so check to make sure you rewrote them all And that's the most important part, because from here you should be able to solve them, because the second part of this question says choose one expression from each part. So again, for me, on the first one, I would choose that one. On the second one, I would choose that one. I would choose that one. I would choose that one. I would choose all of the ones where I'm adding and none of the ones where I'm subtracting. Okay, and then I would go through and solve for each one of those, which I'm not going to. I don't need to do that here, but go ahead and go through and solve and explain why. Why did you choose the expression? And I've already explained me, because I like to use the word combine and think about combining things, like on this one right here, because one of these sets is negative and one is positive. Then I'm thinking all of these are going to cancel with those, so I know it's a subtraction problem, and my answer is going to be a negative number since there are more negatives. Okay, because I'm still thinking of combining them, just understanding that positive and negatives will cancel each other out. Okay, and that's it for this video, looking at how do we change problems from addition to subtraction, back and forth, which one do you like best, and then the thing to note, which is not on here, but we won't be using, from here on, we most likely won't be using the whole, to show that it's a positive, we'll just be putting a 5. It's assumed that it's positive if there's no sign in front of it. If it's negative, there will be either a minus or a negative in front of it, one or the other. So that notation is going to look a little bit different from here on.